Which of the following points is the reflection point A of a ray of light that passes through the point 1, 2 and then continues to pass through point 5, 3 after reflecting on the x-axis? Let's try to understand the problem graphically first. So we'll consider our coordinates axis. Now we have a ray of light that is incident on the x-axis because x-axis is a mirror. So let's say we have a ray of light which is incident on the x-axis at a point A, and then this particular incident ray of light is going to pass through a point. We're going to name it as point P, having the coordinates 1, 2, and then after reflection at point A, it is going to get reflected, and let's say it gets reflected, and as it gets reflected, it passes through another point. We're going to name it Q, having the coordinates 5, 3. Our goal will be to determine the coordinates of point A. Now let's name the coordinates of point A as x, 0. Our goal will be to determine the value of x, and that's going to help us obtain the coordinates of point A. Now, from the laws of reflection, what we'll do, we'll first begin by drawing the normal ray. So this is the normal ray NA, which is incident, which is perpendicular to the x-axis. Now, from the laws of reflection, we know that PAN, this angle will be exactly equals to the angle of reflection, which is QAN. So let us suppose that let angle PAN will be equals to the angle QAN, and let's say they have an angle value of theta or angle measure of theta. Now, since we know that angle, so let's call this point as point B, since we know that angle NAB equals to 90 degree, we know that. This implies that what will be the value of angle QAB. So QAB, that measure is going to be 90 degree minus theta. So this is the angle measure, 90 degree minus theta, and we also need to find out the angle BAP, angle BAP. So that's going to be equals to, we'll take 90 degree minus theta, add it to angle QAN, which is positive theta, and then angle NAP, which is also theta, and that's going to give us a value 90 degree plus theta. So this is number 1 and this is number 2. The reason why we're defining the angle QAB and angle PAB is because we are going to determine the slope of the line AQ. Also, we'll find out the slope of AP, because by definition, how can we define the slope of any line? All you have to do is find the tangent of the angle it makes with the positive direction of x-axis. Okay, so let's write. So let's begin with AQ. Now, since the reflected ray AQ makes an angle of 90 degree minus theta with the positive direction of x-axis, we can define its slope. So slope of AQ, that will be given by, so let's call it M1. So this will be equals to tangent of the angle that it makes with the positive direction of x-axis. So that's tangent of 90 degree minus theta. So this will be equals to, we can also define the slope of the ray AQ because we have the endpoints A as well as Q. So in the denominator, what we'll do, in the numerator, we will first begin by taking the difference of the y coordinate. So that's 3 minus 0. And then in the denominator, we'll take the difference of the x coordinate. So that's 5 minus x. Fine. Now, what's the value of tangent of 90 degree minus theta? That's a standard value of cotangent of theta. So this will be equals to 3 over 5 minus x. We're going to label this as equation number 3. Next, what we'll do, we'll consider the incident ray PA, which is making an angle 90 degree plus theta with the positive direction of x-axis. So that means slope of PA, that's going to be equals to, so we'll consider tangent of the angle that it makes with the positive direction of x-axis, which is 90 degree plus theta. This will be equals to, what we need is the difference of the y coordinate, so that's going to be 2 minus 0 divided by 1 minus x. So 2 minus 0 divided by 1 minus x. Fine. Now, what's tangent of 90 degree minus theta? We know that that's negative cotangent of theta. The reason is tangent of 90 plus theta means 90 plus theta takes it to the second quadrant where tangent and cotangent function are negative. So, with negative cotangent theta equals to 2 over 1 minus x, or simply we have cotangent of theta equals to 2 over x minus 1. What we have done is multiply both sides with negative 1. So let this be equation number 4. Now what we can do, we can equate equation number 3 and 4 because we have cotangent of theta. So equating equation number 3 and equation number 4, we get 3 over 5 minus x, that will be equals to 2 over x minus 1. So let's cross multiply. Cross multiplying gives us 3x minus 3 equals to 10 minus 2x. So we get 3x plus 2x equals to 10 plus 3. So it's such that we have 5x equals to 13, or simply put, x equals to 13 over 5. So we have obtained the value of x. That is all we needed. So that means coordinate of this particular point A, that's going to be 13 over 5 comma 0. Let's go to our options. So we have an option here, 13 over 5 comma 0. Option B is the correct value.